So I'm just going to talk about some of the main conventions around constant acceleration equations and some of the variables that we'll be using and some of the terminology. Now, when I talk about constant acceleration in class, I tend to use the phrase SUVAT. SUVAT is in fact an acronym, and each letter is one of the variables or some of the information that we've been given. First of all, S bizarrely actually stands for displacement. Now, displacement is different to distance. Okay, although displacement is a measure of travel, it is a measure of travel from a fixed point. So if I was to throw a pen in the air, so there's myself there, and I'm going to throw a pen into the air from a fixed point, which was here, and it goes up and it drops down again and I catch it, the displacement that pen has actually made is zero because it has returned to the fixed point. If, however, I was to throw the pen in the air and it somehow managed to stick to the ceiling 2 meters above from where I threw it, then my displacement would be 2 meters. And in the final example that I would normally use is if I was to drop the pen and I wasn't able to catch it and it fell to the floor and the floor was 1 meter below my fixed point, then my displacement would be denoted as -1 meter. Okay, it's really important that you get your signs correct in SUVAT equations to avoid any errors. U, the next letter, stands for initial velocity. Now, initial velocity, when we're talking about throwing things up in the air, is basically the release velocity. That's sometimes given in the question, or you're sometimes asked to find it, and that's obviously measured in meters per second. And again, we normally take the initial direction of motion as being positive. So most of the time, your initial velocity will be given as a positive, you'll denote it as a positive value. Our third is final velocity. Now, obviously, final velocity could potentially be positive or negative. So if I take the example of my pen into the air, and I wanted to know how far its speed after half a second, then my pen might have only reached this height here. Therefore, it's still travelling upwards. My final velocity would therefore be positive. However, after a certain amount of time, it will have reached its greatest height and it started to fall. And if it was, say, after 3 seconds perhaps, and my pen was here on its way down, the final velocity would be negative. So it's important to know if your initial velocity was positive and your final answer for velocity came out as being negative, obviously that pen or that object has changed direction. It's either falling to earth or it's been thrown up in the air and it's fallen in some below you or whatever, okay? So it's just changed direction. A is my acceleration. Now again, when we're talking about throwing objects up into the air, as soon as that object is released, it is being dragged back to earth by the acceleration due to gravity. And what you find when you throw a pen into the air, it will rise so far, it will reach the greatest height it can, and it will fall to the earth with an acceleration of 9.8 meters per second every second. Now, sometimes this varies. If you do physics, they may denote it as 9.81, but the exam papers at the moment denote it as 9.8. Now, if you recall, I said that we would normally set our initial velocity as being positive. Now, if we're throwing something up into the air, then acceleration is always acting downwards. That would have to be denoted as negative. So you need to be very careful as to whether you're throwing something up or just dropping it. Acceleration as well, we would normally denote as a double arrow. And obviously with gravity, that would be acting downwards. My final value is time measured in seconds. And that helps us denote